Hi everyone, we're going to talk about the main results of my article related to the use of natural fibers in biocomposites and their evaluation in machinability processes. The problem and motivation. Most mechanical components are manufactured in steel, producing 1 ton of steel generates around 1.8 tons of carbon dioxide, strongly contributing to climate change. In contrast, natural fibers such as Cabuya offer a lighter, corrosion-resistant option with lower environmental impact. Material and component design. A Cabuya fiber epoxy resin biocomposite was developed and a T-shaped mechanical support was manufactured as a case study. Tensile and machinability tests were performed with different fiber orientations, using the Taguchi method with analyzed rules, machining type, and surface finish.
According to our methodology, we do first the strength test. For that, we make some specimen with epoxy resin and Cabuya fiber. According to the universal testing machine, the random fiber orientation, it resists like 350 newtons. In 90 degrees, it resists 1000 newtons. This was the fiber orientation that resists most. With 0 degrees, it resists 100 newtons. And finally, for 45 degrees, it resists 180 newtons. Later, we do an design of experiment, a DOE, specifically the Taguchi method. For that, we specify two machining processes, drilling and face milling. In drilling, we determine three factors: fiber orientation, cutting speed, and feed rate. And for face milling, we determine four factors: fiber orientation, cutting speed, feed rate, and axial depth of cut, with 4 levels each one. As we can see in the pictures, the feed rate was the most important fact in the machining process. Our machining plan with those specifications, and as we can see, drilling was not that hard as we thought at the beginning. Later we did a face milling with those specifications, and also it was easy to do the face milling too in this compound.
Now, impact and sustainability. The biocomposite developed from Cabuya fiber and epoxy resin represents a promising alternative to conventional materials, both for its performance and its environmental and social benefits. Cabuya fiber, being a natural and renewable resource, reduces dependence on synthetic fibers such as glass or carbon, whose production requires high energy consumption and generates greater carbon emissions. From a sustainability perspective, the incorporation of natural fibers is important because these contribute to boosting local economies, reducing environment impact, and valuing agricultural resources. Now, prototype demonstration. For the prototype demonstration, the first step was to create the mold. We used SolidWorks software to do this. Once the design was defined, we decided to manufacture the mold using 3D printing. The material to the 3D printing was PLA, proved to be a convenient material as it is a relatively flexible and brittle, making it easier to remove the part. With the molds ready, the resin was cast with Cabuya fibers, following the curing and post-curing process previously defined in the laboratory. After the full drying time was complete, the part was carefully removed from the mold, resulting in a T-shaped plate, like the image we can see here. This part represents the final prototype, ready for both machining and evaluation under real-life conditions, like we seen before in this video. And that's all. Thanks for watching.